question here, which is PCl5 dissociates into PCl3 and Cl2. We have initially 5 moles of PCl which are placed in a 200 liter vessel which has 2 moles of N2, and the container is maintained at 600 Kelvin. The equilibrium pressure is 2.46 atm. The equilibrium constant Kp for dissociation of PCl5 is dash into 10 to the power minus 3. We have to report the answer to the nearest integer. So let's have a look at this problem. So first of all, PCl5 initial PCl5 will dissociate into PCl3 and Cl2, and it will dissociate to a certain number till the equilibrium is achieved. So what we'll do is uh, we'll write the equation at time equal to 0. We have initially 5 moles of PCl5. Now we'll assume we'll write the moles of PCl3 and PCl2 at equilibrium in terms of alpha. So initially, so at equilibrium, the moles of PCl3 and Cl2 will be 5 alpha respectively, and moles of PCl5 will be 5 into 1 minus alpha. Now since we know that the from the ideal gas law we know that pressure equal to nRT by V. So we have been given the total equilibrium pressure as 2.46 atm. Now we have to calculate the total number of moles of each component. So for PCl5, its moles will be 5 into 1 minus alpha. For PCl it will be 5 alpha, and Cl2 also it will be 5 alpha. But and we have to remember that we have to keep in mind that there will be 2 moles of N2 also, as it has been given in the question, and it does not react. So we will have 2 moles of nitrogen also. Now we'll do the calculation, and upon calculating we'll get the value of alpha is 0.6. Now we have to calculate the equilibrium constant Kp, which is basically given by product of partial pressures of products upon divided by partial pressure of reactant. Now we can, using the Dalton's law of partial pressure, we can use in this manner. We can basically write the partial pressure of each component in terms of mole fraction. So finally we can write this as mole fraction of PCl3 multiplied by mole fraction of Cl2 divided by mole fraction of PCl3 multiplied by Pt. Pt is our total pressure, which is 2.46 atm. Then we'll calculate the partial pressure for each component. For PCl3 it comes out to be 0.3. Note that while calculating the total number of moles, we have to calculate the number of moles of PCl5, PCl3, PCl2 and nitrogen, because nitrogen is also present in the vessel, so it cannot be ignored. So total number of moles for PCl3 is 3, and hence the mole fraction for PCl3 is 0.3, mole fraction for Cl2 is 0.3, mole fraction for PCl5 is 0.2. Now we'll use the formula of Kp, and it comes out to be 1.107 atm. Okay, so and our answer is 1107 atm.